Alright kids, here we go. This is Wednesday's material, so this is for 4/8/20. Alright, today's the 6th. Okay. Alright, so this is 7.2 and 7.3 continued. Applications of the addition and subtraction formulas. So you saw how we could use those formulas for Monday stuff. Now how else can we apply these formulas? And like I told you on Monday, I warned you, this is a little bit more difficult. It's just a little bit more thinking. Okay? But once we get down to the formula, then it's old news. Alright, what if I told you to find sine of 105 degrees? And if you go on your unit circle, 105 degrees is not famous. Okay? Go to 90 degrees, and then our next famous spot is 120 degrees. So how are we supposed to get 105 degrees? Okay? So let me write that down. 105 degrees is not famous. And normally when angles aren't famous, we have been drawing them, right? We've been drawing non-famous angles, building the sides and the quadrants, but it doesn't give us any other information. It doesn't say sine is negative and cosine is positive, so we can't build this angle. So instead we're going to use our addition and subtraction formulas. Okay? How can we make, put in parentheses or quotations, 105 degrees with famous angles? Okay, how can we build that? And since we're using addition and subtraction formulas, we should be using those operations. Okay, so 105 degrees is actually equal to 60 degrees plus 45 degrees. And 60 degrees and 45 degrees are famous. So instead of trying to find this weird sine of 105 degrees, we can rewrite this as not sine of 105, but sine of 60 degrees plus 45 degrees. And that's where we can use our addition formula. So now apply formula. Okay. This one isn't too bad, but they get a little bit more tricky, you'll see. Alright, I'm going to pull my pencil out. So sine of 60 degrees plus 45 degrees is, what's the formula? Sine of the first times cosine of the second plus sine of the second times cosine of the first. That's all degrees. Put my little degrees in there. Alright, where do we find these sine of 45, cosine 45 degree pieces? The unit circle, since they're famous. Alright, what's sine of 60 degrees, my lovely people? Don't screw this up like I screwed up the quiz. Square root of 3 over 2. What's cosine of 45? Square root of 2 over 2. Plus, what's sine of 45? Square root of 2 over 2. Times cosine of 60, 1/2. So that all comes from the unit circle. Alright, let's multiply this together. Square root of 6, you can multiply those roots because they're the same kind of root. Over 4 plus square root of 2 over 4. Don't try to do some craziness and try to simplify 6 and 4. That's not 6. That's the square root of 6. So don't do some craziness. You can then add these together as one fraction. Square root of 6 plus square root of 2 all over 4. So there is sine of 105 degrees. So that's how we're going to apply these formulas. Again, they get a little trickier, but that's how we're going to do it. Alright, let's do another one. I'm looking at my notes and seeing what I want to do. I'm just checking this stuff out. what if I wanted to do cosine of negative 15 degrees? Cosine of negative 15 degrees. Well, that's not famous, right? We got 30, 45, 60, 90. We don't have 15. So how can you rewrite negative 15 degrees with famous angles? Using addition and subtraction. And somebody has shouted out, Sam, negative 15 degrees is equal to 30 degrees minus 45 degrees. Everybody cool with that? Okay, so negative 15 degrees. And here's where I need you to be careful. When you apply this formula, I need you to watch your signs. So, cosine of 30 degrees minus 45 degrees. That's what we're going to do. We're going to apply the sine for the cosine formula. But before I do, I need you to be careful. If you're using the subtraction formula, this is what I want you to see this as. 30 degrees minus a positive 45 degrees. Okay, so you're not doing negative 45. That's backwards. So 45 degrees and negative 45 degrees are two different spots on the unit circle. So you're doing a regular 30 degree and a regular 45 degree. And this, you're going to apply the subtraction formula. So I don't want you to do a negative 45 degrees. That's walking backwards. That's something else. So, that would be this. So you might say, well, Sam, what's the difference? That would be this. Let me write it. I'm going to write it over here. So aside. If you saw this as cosine of 30 degrees and negative 45 degrees, if that's what you were going to walk, there should be a plus sign here. And what's the difference between these two problems? Mathematically, like a minus is a plus minus. They still equal negative 15. However, what's the difference between these formulas? This is a subtraction formula, that's an addition formula. So will it work out to be the same? You go find out. Is this formula, if you walk this correctly, and this formula the same? Like, does the answer come out to be the same? You go find out. It may be. I'm telling you to do it because off the top of my head, I don't know. So I just want you to be careful of your angles and careful of your walking. So I'm just trying to make it as simple as possible. A positive 30 degree walk and a positive 45 degree walk, we're going to apply the subtraction formula. Alright, so this is going to be, what is this formula? Cosine of the first, cosine of the second, so see, positive 45 degrees. And since this is a subtraction formula, it's going to switch to plus, sine of the first, sine of the second. So just be careful. Okay? And where do we find these at? The unit circle, since they're famous. Alright, cosine of 30 degrees. That is, anybody got it? Anybody got it? Yes. Square root of 3 over 2. Cosine of 45 degrees. Square root of 2 over 2. Plus sine of 30 degrees. Okay. And sine of 45 degrees. Square root of 2 over 2. So square root of 6 over 4 plus square root of 2 over 4. Oh, look at that. Is that the same thing as the last one we had? I think so. Equals square root of 6 plus square root of 2 over 4. Or is it something else? Yeah, it's the same thing. Okay. So there's cosine of negative 15 degrees. Are you ready for the ones that are a little bit harder? So let me fix these directions. So I'll label this B. The other one was A. Fine. Here's C. I'm thinking. Sine of pi over 12. Now it's a little bit harder, because now you have to make pi over 12 famous, because it's not famous. And we can't build it in a triangle because we don't have any other information. Okay, so make it using famous angles. Okay. All right, this guy you can think of a couple different ways. This is probably one of the harder problems to do. I think either way you go, the train of thought is going to take a little bit of practice. So pi over 12 is half of pi over 6, right? What's half of pi over 6? If you do that math, pi over 12, because you really just multiply. Okay. So pi over 12 is half of pi over 6. Is that cool? Alright, I'll just do a little circle here. So this is pi over 6, and we cut it in half. That's pi over 12. Okay, that's what we did. But in terms of degrees, pi over 6 is equal to 30 degrees, right? Well, if we cut this radians in half, we're cutting the degree in half. So what's half of 30 degrees? 15. So pi over 12 is actually 15 degrees. Okay. So half of 30 is 15 degrees. So it's like, Sam, okay, and why do we need to know that? Well, now that we know that, it's easier to try to add up to get 15 degrees or 105 degrees, adding whole numbers, subtracting whole numbers, than trying to add and subtract fractions and get pi over 12. Okay, I'll say that again. It's easier to add or subtract whole numbers and add up to get 15 or subtract to get 15 than to add or subtract and work out to get pi over 12 using famous guys. So that's why I turned it into a degree. Alright, so what we're trying to really find is, try to grab this. Sine of 15 degrees. And we just work with the 15 degree guy. What do you guys want to use? Sure, 45 minus 30 degrees. And again, be careful. You are using 45 degrees minus a positive 30 degrees. So just be careful. Okay, so we're using the subtraction formula, and both the degrees are positive. They're going in the counterclockwise direction. Okay. Alright, so what is this formula? This is equal to sine of the first times cosine of the second. So minus, problem stays minus for sine, minus sine of the second times cosine of the first. Okay. Alright, so where do we get this from? Unit circle. These are famous degrees now. Square root of 2 over 2 times cosine of 30. We just did this. Square root of 3 over 2 minus sine of 30, 1/2, times square root of 2 over 2. Square root of 6 minus square root of 2. Both of them are over 4. Yeah, it's pretty popular right now, the examples I'm using, but whatever. I just need you to get the point. Alright, that was the first way you could have done it. So going back to pi's and saying, well, pi over 12 is half of pi over 6. So half of 30 is 15 and going from there. Okay. What's the other way I could have done it without degrees? Okay, so or sine of 15 degrees. That was our problem. Or not, no, we started off with pi over 12. So here's the other way, and this other way is sometimes what you're going to have to do. Sometimes you can't make it degrees. You can't say half of. It doesn't work out. Pi over 12. So how could I have done it another way? This one takes a little bit more thought, okay? Because you're actually playing with fractions. So here's a mistake. So you're trying to add or subtract fractions to get pi over 12. That's what you're trying to do. Some people will do, like, they'll lose their minds forcing these fractions, and they'll say pi over 6 plus pi over 6 equals pi over 12. You learned how to subtract and add fractions like years ago. 6 plus 6, you do not add those and get 12. That is wrong, but people will do the craziest things with these fractions. Okay? So it's harder because when you're adding and subtracting fractions, you have to get CDs. So it's like manipulating, trial and error, trying to forget what fraction gives you pi over 12. Okay? It turns out that pi over 12, and this just comes with practice. Okay? Pi over 12 can be broken up as pi over 4 minus pi over 6. It's like, Sam, how was I going to know that? Okay. Well, it's going to come with practice. So this is how. It's like, well, if you make these guys pi over 12s to begin with, right? How do I make this a pi over 12 multiplied by what? 3 over 3? 3 pi over 12 minus 2 pi over 12? 2 over 2. So 3 pi over 12 is really pi over 4. 2 pi over 12 is really pi over 6. And that is pi over 12. So you really could have done it with these guys. Okay? So you could have done sine of pi over 4 minus pi over 6 and gone to your unit circle, and it would have been all the work that we did up here. That's a 45-degree angle, that's a 30-degree angle. Sometimes you have to manipulate the fractions and do it this way. Okay. Again, a subtraction formula, so this is a positive angle and another positive angle, so be careful of that. So that's the other way that's tougher for these problems. And that's what's going to take practice. Alright, let's do another one. What time is it? 17:48. Yeah, let's do one more. A, B, C, D. You guys miss my singing in class? I know. Cosine. I'm stealing this from the book. Just an FYI. Of 11 pi over 12. Cosine of 11 pi over 12. So we have to make this add up to, or subtract, pi over 12. I wish I was in class for you guys to give me suggestions. And I don't tell you right away. So let's see. Common mistake. Let me show you mistakes. Pi over 6, because that's famous, right? Plus 6 pi over 6. Oh, that's 11. 5 plus 6 is 11 pi over 12. Let's stop it right now. Okay. Be careful. So, let's try it. Let's do 11 pi over 6. 11 pi over 12, sorry. Like, Sam, how would you do it? Well, I know pi over 3s and pi over 4s are famous. So, if I multiplied by this by 3 over 3 and this by 4 over 4, would that give me it? That would give me 7 of them. That would not give me 11 of them. Okay. What if I did pi over 2 plus pi over 6? If I multiplied by 6 over 6 and 2 over 2, that would give me 8. Okay. So does that work? Nope, that doesn't give me 11. So if I did subtraction, I'm just trying something, guys. 12 pi over 12, that's 1 pi, right? Minus 1 pi over 12. But that's not famous. Great, I should have probably figured this out before I even gave it. That guy is a... Oh, I'm so slow. Guys, get it together, Sam. What adds up to be 11? 8 and 3, right? 8 12s plus 3 12s is 11 12s. Now simplify these. But you see how I was trying? You see how this is going to be trial and error? There's my trial and error. So this is what's going to be a pain. What is that? Factor out of 4, right? That's 3 pi over 4 plus 1 pi over 4. Oh, look at those. Those are famous. We found it. So if you take this guy and just try to add up, like, what 12s plus what 12s gives you 11 12s, and then go see if they simplify to famous guys. Okay? Sometimes it's easy, sometimes it's hard, sometimes you got to be a little slick. Okay, but you see all my tries and my thought process. So it was a good thing I didn't know how to do this right away. It's gonna come with practice. This is the knowing part. So again, 11 12s, 8 12s plus 11 12s, or 8 12s plus 3 12s is 11 12s. But when you simplify these guys, they simplify to famous guys. Okay, so cosine of 11 pi over 12 is really equal to cosine of 3 pi over 4. Wait. That's not right. That's 1/4. If I factor out a 4 here, that's 2/3. Ooh, guys, I can't do math. Can't do math. Factor out of 4, you get 2. Factor out of 4, you get 3. They're still famous. I was like, wait a minute, that ain't right. 2 pi over 3 and pi over 4. 2 pi over 3, so simplify your fractions correctly. Plus pi over 4. Still famous. We're good to go. Alright, cosine of that, so that is addition formula. So this is going to equal cosine of the first times cosine of the second minus, it switches, cosine switches, sine of the first times sine of the second. And again, where do I find this stuff since it's famous? On the unit circle. Unit circle. Alright, cosine of 2 pi over 3, that's the second quadrant, so that's negative 1/2 times cosine of pi over 4 square root of 2 over 2 minus sine of 2 pi over 3 square root of 3 over 2 comma, or times square root of 2 over 2. So you know that unit circle by heart. You should know it by heart already. I'm just double checking, did I do that right? That's a negative, yeah, okay. So this equals negative root 2 over 4. Make sure you multiply straight across. Minus root 6 over 4. And then when you put that together, negative root 2 minus root 6. You can factor out a negative if you want, but it's not going to make a difference. It's still going to be there. There's your answer. So that was a good example of how you're just going to kind of do trial and errors with fractions sometimes, and that's what makes it harder. Okay? But our best route with this was just adding up to get 12s, and then making them simplify to the famous guys. That was a good example. Stole from the book. Alright guys, so that's Wednesday's lesson. That's how we can apply these addition and subtraction formulas. And so this material on the homework won't pop up until Friday. Okay, so the stuff that I assign that is due on Friday will have this stuff on there. Alright, see you later.